If I fire one single electron through two slits, one at a time, why do I get a wave pattern? I want you to picture a wall with two narrow slits cut into it, and behind that wall, a screen. You've seen the drawing 100 times, and you've probably seen the results too, a set of bright and dark stripes on the screen, like a barcode made of light. That's interference. Now here's the real problem. That pattern makes sense if waves are coming through both slits at once. Water waves, sound waves, light waves, they can overlap, and where they overlap, you get reinforcement or cancellation. Fine. But what if I don't send a wave? What if I send one electron? Just one, not a beam, not a spray. One lonely little thing that leaves the gun, flies through the apparatus and hits the screen as a single dot. You might guess it goes through one slit or the other and lands somewhere. A dot, just a dot. You do it again, another dot, again and again. And at first it looks like random pepper sprinkled on the screen. But after enough dots, the interference pattern appears. Not because two electrons are meeting each other. They aren't. You're sending them one at a time with seconds between them. Each one is alone. It has no partner to interfere with. So what is interfering? That question is not a detail. That question is the entire story. Most people learn interference as a geometry trick. Path difference gives bright or dark. And that's where real understanding dies. Because a lot of interference teaching goes like this. Draw two slits, draw two rays to a point on the screen, calculate the difference in path length, and if the difference is a whole number of wavelengths, you get bright. If it's half a wavelength, you get dark. You memorize it, you do the homework, you pass the exam. But none of that tells you why a place on the screen can be forbidden. None of that tells you what it means for something to cancel when there's nothing colliding. None of that tells you why the pattern survives even when you fire particles one at a time. The danger is that you start thinking interference is just a diagram and a rule, like a recipe. You don't build a picture in your head that can survive pressure. So let's do something different. Let's not begin with waves as an abstract object. Let's begin with a mechanism you already understand. Timing. Forget waves for a moment. Think of interference as timing. Two influences arriving in sync or out of sync. Imagine a child on a swing. You know how to make the swing go higher. You wait until the swing comes toward you and you push at just the right moment. Push at the wrong moment and you don't help. You might even slow it down. Now suppose two people are pushing the same swing. If both push forward at the same time, perfectly timed, the swing goes higher and higher. That's constructive interference. But if one pushes forward while the other pushes backward, same strength, same timing, but opposite direction, the pushes cancel. The swing doesn't gain motion. That's destructive interference. What makes this powerful is that nothing mystical happens. No energy disappears into nothingness. It's simply that the pushes are out of step. One cancels the other. Now take that idea and remove the swing. Think of any system that responds to periodic pushes. A guitar string, a drumhead, air in a flute. When the pushes line up in time, the response grows. When they arrive out of phase, they cancel. That is the heart of interference. Two contributions arriving at a point with a timing difference. Waves are just the neat mathematical way of describing a pattern of such timed influences across space. And suddenly the path difference rule starts making sense as a timing rule. If one path is longer, the wave arriving from that path is delayed. If the delay is exactly one full period, shown one wavelength in distance, then the crests arrive together, bright. If the delay is half a period, a crest arrives with a trough, dark. So far, so good. But it's still too easy because you can always say, well, the wave from slit A and the wave from slit B overlap at the screen. And that's true for water waves or sound waves. It's even true for classical light waves if the intensity is high enough and you treat light as a continuous electromagnetic wave. But now I want to press on the place where people's understanding breaks. Here's the first thing that sounds wrong. Destructive interference doesn't mean the wave disappears. It means the detector gets zero net signal. This is one of the most important points because if you misunderstand this, the rest becomes nonsense. When you see a dark stripe in an interference pattern, it is incredibly tempting to think nothing arrived there. The wave canceled out, so there was no wave. But what does no wave mean physically? Take sound as an example. You can actually do interference with sound in a way your body can feel. Play the same pure tone from two speakers. Walk around the room. At some points, the sound is loud. At other points, it almost vanishes. You can stand in a quiet spot, take one step, and suddenly the sound returns. Did the sound disappear in the quiet spot? Not really. What happened is the air pressure variations from the two speakers arrived out of phase. One tried to push the air at the same time the other tried to pull. The net pressure fluctuation was close to zero at your ear. And here's something you can check. If you put a microphone at that quiet point, it records almost nothing. But the air molecules are still moving. Energy is still flowing through the room. It's not like the energy hit an invisible wall and stopped. The energy is redistributed to other places where the waves add. This is exactly why noise-canceling headphones work. They don't destroy sound. They produce a sound wave that is the negative of the incoming wave at your ear, so the net pressure variation becomes close to zero. Your ear responds to pressure changes. No pressure change, no sound. But energy hasn't been magically erased from the universe. It's been converted inside the headphone electronics, and the air motion pattern has been reshaped. So a dark fringe is not a void where reality failed to arrive. It's a place where the net effect at the detector is zero. Keep that firmly in your mind, because it is the key to understanding how something can cancel, even when it's not a material object crashing into another object. Now, with classical waves, we are comfortable saying the wave field at that point is the sum of two contributions, and the sum happens to be zero. So the question becomes, what is being summed? With sound, it's pressure. With water, it's height. With light, it's the electromagnetic field, the electric and magnetic fields at that point in space. And the detector responds to the intensity, which depends on the square of the field amplitude. That's why the mathematical superposition of fields leads to bright and dark fringes. That's the classical story. Now let's make it cruel. We turn the brightness down until only one photon, or one electron, hits the screen at a time. This is where the title earns its arrogance, because this is where most people's explanations become a fog machine. Imagine you have the same double-slit setup, but you lower the intensity of light so far that the detector clicks only occasionally, one photon at a time. You can do this in real experiments with modern equipment, but you don't have to trust it as a claim. You can just follow the logic. Each time the detector registers a photon, it appears as a single localized event, a dot, a click, not a wave spread out across the screen, a particle-like impact. You wait, another click, another dot. At first, nothing looks like a pattern. It's just dots scattered around. But then, after many clicks, the dots begin to cluster in stripes. Bright regions have many dots. Dark regions have almost no dots. The interference pattern emerges as a statistical structure. Now stop and think what that means. If each photon were a tiny bullet that went through one slit, then the pattern should look like the sum of two single-slit patterns, two blobs, not stripes. But it doesn't. If each photon were a wave that split and spread across the screen, then why does it hit as a single dot? And if it is somehow both, what does that even mean in a way that isn't just poetry? This is the point where Feynman said essentially, here is the only mystery. Because the double slit is not just a cool trick, it is the simplest situation in which quantum mechanics refuses to let you keep your classical categories. And interference is the symptom. So how do we make sense of it? The first step is to stop trying to explain it using the wrong thing. If you try to explain single particle interference using classical waves, you'll get stuck at how can one particle go through both slits? If you try to explain it using classical particles, you'll get stuck at why doesn't it form two lumps? So the honest move is to ask, what is the rule nature follows that produces the observed probabilities? And now we arrive at Feynman's central teaching tool. If you remember only one sentence from Feynman, make it this: nature doesn't add probabilities, and she adds amplitudes. That sentence looks innocent. It's not. It's a complete replacement for the way you think about alternatives. In everyday life, probabilities adds If there are two independent ways for something to happen, the chance is the sum. If you can get to the store by walking or biking, the probability you arrive by walking plus the probability you arrive by biking equals the probability you arrive at all, assuming those are the only options. But in interference, that's not what happens. Instead, nature assigns something like a complex number, an amplitude, to each alternative. And then the total amplitude is the sum of the amplitudes for each alternative. The probability is the square of the magnitude of that total amplitude. It's the squaring at the end that creates the interference terms. Now you can say complex number and lose half the audience. So let's keep it simple and visual, like Feynman did. Think of an amplitude as an arrow. An arrow has a length and a direction. The length corresponds to how strong that contribution is. The direction corresponds to something like a phase. The timing information. Two arrows pointing the same way add to a bigger arrow. Two arrows opposite each other cancel. And this is the key. Probabilities don't cancel. Probabilities are always positive. But arrows can cancel. So if nature is adding arrows, then it becomes possible for an event to have zero probability because the arrows for the different alternatives cancel. That is what a dark fringe is in quantum mechanics. Not no particle, but the arrows add to zero. Now you can see why interference is so fundamental. Interference is not a special behavior of waves. It is what happens whenever you are forced to add arrows before squaring. So how do we connect this arrow idea to the double slit? Simple. Each slit represents an alternative. Alternative A. The particle goes through slit 1 and arrives at point P on the screen. Alternative B. The particle goes through slit 2 and arrives at point P on the screen. Classically, you'd say the probability it arrives at P is the sum of the probabilities of those alternatives. Quantum mechanically, you say, the amplitude for arriving at P is the sum of the amplitudes of those alternatives. Then you square. Now, why would those amplitudes have different directions? Because the phase depends on the path length, just like in wave interference. The amplitude arrow rotates as the particle travels. Longer path, more rotation, different phase. So at some points on the screen, the two arrows line up and add high probability, bright fringe. At other points, they point opposite and cancel, low probability, dark fringe, and the whole interference pattern appears. Now, do you see what just happened? We explained interference without claiming that particles are secretly water waves. We didn't have to say the photon is literally split into two pieces. We used a different kind of addition, and we kept the timing intuition from the swing push, because phase is timing. So interference is, at its core, cancellation and reinforcement in amplitude space, not energy space. Now you might ask, okay, but what is this amplitude physically? That's the correct question, and it's where the deepest honesty is required. Amplitude is not a physical quantity like pressure or electric field that you can directly measure. It is a mathematical object used to predict probabilities. It behaves like a wave. It spreads. It has phase. It can interfere with itself. But when you measure, you don't measure amplitude. You get a definite outcome. That sounds abstract until you realize you already accept similar things in other contexts. You don't directly measure probability either. You measure events. Probability is a description of the pattern. Amplitude is like a probability with an extra ingredient, phase. It's probability with the ability to cancel. So one way to say it carefully is, the quantum object is described by a wave function, an amplitude field over space, and the interference pattern reflects how that amplitude field combines from different paths. Now we need to address the sharpest knife in this whole experiment. If the electron uses both slits as possibilities, why does the pattern disappear when we try to find out which slit it went through? Because it does. This is one of the most dramatic results. If you set up a detector at the slits to determine which slit the particle passed through, the interference pattern vanishes. You get the two-lump distribution you expected from particles. Why? Here's the most violent act in quantum physics. It isn't smashing the particle. It's asking a question that removes a possibility. This is another place where YouTube explanations often fall into a trap. They say measuring disturbs the particle. That's sometimes true, but it is not the full story, and if you stop there, you miss the core mechanism. The deeper statement is, interference requires the alternatives to remain coherent, meaning you must be able to add their amplitudes as arrows. If you perform a Witch slit measurement, you make the alternatives distinguishable, the amplitudes. Does no longer add in the same way, because the system now carries information about the path. The two alternatives are not just two possible stories in your head, they are different physical situations in the universe. Let's make that concrete. Suppose you have a tiny light near the slits, and when the electron goes through slit 1, it scatters a photon, and when it goes through slit 2, it scatters a different photon direction. Even if you don't look at that photon, the environment now contains a record of which slit. The electron is now entangled with the environment. The universe has tagged the path. And when the paths are tagged, the phases can no longer interfere in the same way at the screen, because the slit 1 amplitude is attached to one environment state and slit 2 amplitude to another. They're no longer arrows you can lay on top of each other. Interference is fragile because it's about adding possibilities. When you make the possibilities distinguishable in principle, you stop adding them. You treat them as separate, and then probabilities add instead. That is why the interference vanishes. So it isn't that measurement is spooky magic. It's that interference is an extremely delicate effect of keeping alternatives indistinguishable. Now let's zoom out and try to unify everything. We started with classical waves and timed pushes. Their interference is literally the superposition of physical fields. Then we moved to single particles and saw interference as a superposition of amplitudes. Is that the same interference or different interference? It's the same structure with different ingredients. In classical light, the electromagnetic field is the thing that superposes. Intensity depends on the square. That gives fringes. In quantum mechanics, the amplitude field, the wave function, is the thing that superposes. Probability depends on the square. That gives fringes. The difference is not the pattern. The difference is what the field represents. So now we can deliver a deeper insight that many people never hear clearly. Interference is what happens when reality stays undecided long enough to let possibilities cancel each other. That's not poetry. That's a precise statement about the rules for combining alternatives. If you must add arrows and then square, you get interference. If you must square and then add, you do not. Interference is the fingerprint of add first, square later. And the double slit proves that nature, at least at small scales, uses that rule. Now there's still a haunting question left. You can feel it. When we say the electron has an amplitude through both slits, are we saying the electron physically goes through both? Here is where intellectual honesty matters. Quantum mechanics does not tell you a story about what the electron really did between emission and detection in the way a classical trajectory does. It gives you a method for predicting outcomes. And it tells you that if you insist on asking which slit did it actually go through, you are asking a question that changes the experiment and destroys the interference. In other words, you can't have both, a definite path and the interference pattern. That's not because we are ignorant. It's because the concept of a definite path is not compatible with the phenomenon. So what should you say instead? You can say the electron behaves as though it explores both possibilities, and the interference pattern is the result of those possibilities combining. That is careful, and it preserves the predictive power without pretending to know what cannot be defined in the experiment. Now let's tie back to the opening question. If I fire one single electron through two slits, one at a time, why do I get a wave pattern? Because the pattern is not produced by electrons interfering with each other. The pattern is produced because the probability of where an electron will land is determined by the interference of amplitudes, contributions from multiple possible paths. And because those amplitudes can cancel, some places become extremely unlikely. So interference is not a thing waves do. It is a rule about how alternatives combine when you don't know and cannot know which alternative occurred without changing the conditions. That's the deep teaching. Now here's the twist, and it's the kind of twist Feynman loved because it changes how you look at everything. Interference doesn't live at the slits. It lives at the screen. It's not that the slits are making the interference by doing something active. The slits simply provide alternatives. The interference appears because the detector receives contributions from those alternatives and responds to their sum. That means interference is not something happening out there. It's a feature of how outcomes are built from possibilities. And once you internalize that, a lot of quantum weirdness becomes less weird, not because it becomes classical, but because you stop demanding the wrong kind of explanation. The double slit isn't telling you electrons are weird. It's telling you your idea of what counts as an explanation might be too small. You want the electron to behave like a particle with a path or a wave with a spread, because those are the categories you know. Quantum mechanics says the category is different. The fundamental object is an amplitude field whose squared magnitude gives probabilities and whose phase allows cancellation. Once you accept that, interference is no longer a magic trick. It is a natural consequence, and that acceptance is not surrender. It is progress, because now you can predict precisely. You can build lasers, you can build electron microscopes, you can build devices that depend on phase coherence. You can calculate interference in superconductors, in atoms, in molecules, all from one rule: add amplitudes, then square. So here's the final lens I want to leave you with. When you see interference, you're seeing evidence that reality is not built from single events in isolation. It's built from a structure of possibilities that interact before an event becomes real. That is not mysticism. That is the cleanest, most honest summary of what the experiments force us to conclude. And if that feels unsettling, good. It means you're paying attention. Beckon. Because the universe isn't required to match the categories your brain evolved to use on rocks and spears. Interference is the universe politely telling you your intuition works in the wrong regime. And once you stop trying to shrink interference into a geometry trick, you can finally understand it as what it really is: the ability of possibilities to cancel.